Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Now, in this first video lecture of week 13 for the course Differential Equations, today we are going to learn about the case number 4 for the solution of higher order non-homogeneous linear differential equations. Case number 4 means that when the function is in the form of e power ax multiplied v, where v is a function of x which is polynomial. It's mean that the function f of x will be exponential and multiplied with the polynomial or trigonometric function. Then how we will find the particular solution? Because the non-homogeneous linear equation has two solutions. One is the complementary solution and other is the particular solution. Now, the particular solution in the case when the function on the right hand side f of x is in the form e power ax multiplied v, then the particular solution will be equal to 1 over the differential operator f of d into e power ax multiplied v. Now, out of this e power ax and 1 over f of d plus a, replace this d by d plus a multiplied v function. V will be the function of x which is a polynomial, in this case number 4. Now this v will be also the maybe the function of trigonometric, but one will be the exponential function. Actually this is the product of two functions. One is the exponential function and other may be polynomial or maybe a trigonometric function. Then we can find the particular solution by using this procedure. Out of e power ax, taking out e power ax and 1 over replace d by d plus a multiplied v function. It is called exponential shift theorem for inverse operator. 1 over f of d actually the inverse operator. Now the proof for this formula, the proof for this exponential shift theorem, if u is a function of x, then derivative of e power ax multiplied u by using the product rule, first derivative of second plus second derivative of first. Now taking common e power ax and u common, we can write e power ax multiplied d plus a into u. Now again derivative d square into e power ax multiplied u. Now using again the power rule for the again derivative, you see over here, suppose this is the first function, e power ax into u is the first function and d plus a is the second function. So e power ax and u is it is, and the derivative of this expression d square plus dA. Now so first derivative of second plus second, this is second, and the derivative of e power ax a into e power ax, and now u is as it is. So this second order derivative can be written as e power ax into d square plus 2ad plus a square into u. Again common e power ax into u. So the second derivative, the simplest form, this is actually the formula a square plus b square plus 2ab. So second derivative of e power ax into u is equal to e power ax into d plus a whole square into u. Now continuing this process of successive differentiation, we obtain n times derivative of this expressions. N time derivative e power x into u is equal to e power ax into d plus a power n into u. Hence f of d into e power ax into u is equal to e power ax into f of d plus a into u, where f of d is the polynomial operator of order n. Now operating on both sides by 1 over f of d. 1 over f of d on the left hand side in this expression, you see over here 1 over f of d into f of d into e power ax into u is equal to 1 over f of d into e power ax into f of d plus a into u. Now f of d cancel. we obtain in the left hand side e power ax into u, and 1 over f of d into e power ax plus e power ax into f of d plus a into u. Let this f of d plus a into u is equal to capital V, where V is a function of x. This V may be a polynomial or maybe a trigonometric function, but one is the exponential function you see over here. So that u is equal to 1 over f of d plus a into V, then e power ax into 1 over f of d plus a into V is equal to 1 over f of d into e power ax into V. So in short, we can say that the particular solution for this expression is equal to e power take out e power ax and replace this d by 1 of d plus a, you will find a particular solution. We can easily find a particular solution for the higher order non-homogeneous linear differential equation. So in short, the working rule for the particular function when exponential function is multiplied with the polynomial or with the trigonometric function, then for the particular solution, the working rule take out e power ax, and in f of d replace every d by d plus a, so that f of d converts to f of d plus a. Then operate 1 over f of d plus a upon v, which will be one of the cases already discussed. Now, for example, we have the third order non-homogeneous linear differential equation y triple dash plus 3y double dash minus 4y is equal to x e power minus 2x. Now you see over here e power minus 2 is x, the exponential function, and other is a polynomial function. So at the right hand side, the function f of x is in the form of exponential function multiplied with the polynomial. So in this case, now we are going to discuss the procedure how to find the particular solution in this case. Since this is the non-homogeneous linear differential equation, so the complete general solution of this differential equation will be equal to the complementary solution plus particular solution. Now first of all, to find the complementary solution, for the complementary solution you see over here d cube plus 3d square minus 4 into y is equal to 0. For the complementary solution, taking the homogeneous part of this non-homogeneous differential equation, this is the homogeneous part. Now this homogeneous differential equation has y is equal to 0, the trivial solution, and for the non-trivial solution we take the auxiliary equation. You see over here m cube plus 3m square minus 4 is equal to 0. Now the complementary solution of the non-homogeneous differential equation depend on the nature of roots of this auxiliary equation. So to find the roots of this equation, for example, we put m is equal to 1. In the above this equation, if we put m is equal to 1, we obtain 1 plus 3 minus 4 is equal to 0, which implies that 0 is equal to 0. So 1 is the root of this polynomial. Now to find another two roots for this polynomial by using synthetic division, you see over here. For the synthetic division, the coefficient of m cube is 1, the coefficient of m square is 3, the coefficient of m is 0, and the constant term is minus 4. And now put the root which we have already find by analysis. So now this one is it is multiplied 1 with this one, we obtain 1. Now adding these two, 4 multiplied 1, 4, 0 plus 4, 4, and now again this 4 multiplied with this root, we obtain 4, minus 4 plus 4, 0. Now the Laplace equation from this synthetic division will be m square. Now this is actually the coefficient of m square. So m square, and this is the coefficient of m plus 4m, and this is the constant. So this is the quadratic equation. So we can easily solve this quadratic equation by using the quadratic formula or by using the factorization. Like you see over here, this is actually the factorization. M plus 2 whole square is equal to 0. A square plus b square plus 2ab formula. We obtained m plus 2 whole square. And m plus 2 whole square mean m plus 2 into m plus 2 is equal to 0. And now m is equal to minus 2 and minus 2. So in this case, the roots are real and repeated. One root is the real and different, and other two roots are real and repeated. So there will be two cases for the complementary solution. This is actually the case when the roots are real and different, and this is the case when the roots are real and repeated. So c1 e power m1x plus c2 e power c2 plus c3x e power m2x. So suppose the first root this is equal to m1, and these two roots suppose called m2. So c1 e power x plus c2 plus c3x into e power minus m2x, and m2 is actually minus 2. Now the particular solution for this case, when the exponential function is multiplied with the polynomial, you see here this is actually the right hand side function of the given differential equation. In the given differential equation we obtain x e power minus 2x at the right hand side. So the particular solution will be equal to 1 over the differential operator. This is actually the inverse operator of the given differential equation, d cube plus 3d square minus 4 into the right hand side function. So you see over here, by using the shift theorem, take out e power minus 2x and replace this d by d plus minus 2. So replace d by d minus 2. Now e power minus 2x and replace this d by d minus 2. So d minus 2 whole cube plus 3d minus 2 whole square minus 4 into x. So dear students, note that you see over here, take out e power minus 2x and replace d by d minus 2. Actually this is d plus a, but the value of a is minus 2. That's why we replace d by d minus 2. So d minus 2 whole cube plus 3 into d minus t whole square minus 4 into x. Now using the cube formula, a minus b whole cube, we obtain a cube minus b cube minus 3a square b minus 3ab square. And you see over here d cube minus 8 minus 6d square plus 12d. Actually the a minus b whole cube formula is equal to a cube minus b cube minus 3ab square and plus 3ab square. And we can say that actually the value of b is minus 2. So simply we can write a cube minus b cube minus 3ab minus 3a square b and minus 3ab square. A cube plus b, a cube minus b cube minus 3a square b minus 3ab square. So using the formula we obtain d cube minus 8 minus 6d square plus 12d. Now this is the formula, a minus b whole square, a square plus b square minus 2ab, and multiplying with 3, and now minus 4 is as it is. Now after simplifications we obtain, you see over here, after simplifications particular solution e power minus 2x divided by d cube minus 3d square into x. And since now x is the polynomial, so for the polynomial we have already discussed in the previous video lecture that taking out common the lowest degree term, d square is the lowest degree term, so minus 3d square is the lowest degree term. So taking out common this term, we can write minus 3d square into 1 minus d by 3 into the polynomial x. Now shift this binomial 1 minus d power 3 to the denominator, we obtain 1 minus d by 3 power minus 1. Now applying the binomial theorem, binomial expansions, 1 plus nx plus n into n minus 1 divided by 2 factorial x square and so on. But since this polynomial has degree 1, so we need only the first two term of the theorem, 1 plus nx. So this is n and this is the x term in the binomial expansion, 1 plus x power n. So 1 plus nx, now this is the n, multiply this n with this second term, so 1 plus d by 3 into x. Now implies that neglecting the d square in the higher power of d, we obtain e power minus 2x divided by 3d square into 1 plus d by 3 into x. So this is actually called the derivative. So 1 multiplied x, so x, and the derivative of x, you see over here the derivative of x is 1. So we obtain now e power minus 2x divided by minus 3d square into x plus 1 over 3. Now the 1 over d square, actually 1 over d square mean double integration. So taking single integration for x plus 1 over 3 with respect to x, we obtain e power minus 2x divided by minus 3d, and the integration of x is x square by 2, and the integration of 1 over 3 is equal to x by 3. Now again integration, 1 over d mean integration with respect to x. So e power minus 2x divided by minus 3, and the integration of x square by 3 plus integration of x by 3. You see over here, integration of x square by 3, actually integration of x square by 3 cube, adding power 1 to the above power, x cube divided by 2 and divided by 2 3 multiplied 6, and you see over here, this is actually now taking again integration of x square by 2 plus x by 3. So the integration of x square by 2 mean x cube divided by 2, and 2 multiplied 2 will be equal to 4. You see over here, and the integration of x is x square by 2 and 2 3 the 6. So we obtain the particular solution e power minus 2x divided by minus 3 into x cube by 4 plus x square by 6. Now putting this particular solution and the complementary solution in the equation number A, we obtain the general solution c1 e power x plus c2 plus c3x into e power minus 2x minus e power minus 2x divided by 3 into x cube by 4 plus x square by 6. Now another example, second order differential equation, second order non-homogeneous differential equation, y double dash plus 4y minus 12y is equal to x minus 1 into e power 2x. So again the exponential function is multiplied with the polynomial. So there are two solutions for this second order differential non-homogeneous differential equation. One is the complementary solution and other is the particular solution. So first of all, find the complementary solution. For the complementary solution, taking the homogeneous part of this non-homogeneous differential equation, d square plus 4d minus 12 into y is equal to 0. So y is equal to 0 is the trivial solution, and for the non-trivial solution we write the auxiliary equation m square plus 4m minus 12 is equal to 0. Now by sum and product we can write m square plus 6m minus 2m minus 12 is equal to 0. Taking common m from these two terms, m into m plus 6, and taking common minus 2 from these two terms, minus 2 into m plus 6 is equal to 0. And now we can write m minus 2 into m plus 6 is equal to 0. So this implies that m minus 2 is equal to 0 mean m is equal to 2, and m plus 6 is equal to 0 mean m is equal to minus 6. So there are two unequal real roots. So the complementary solution is equal to c1 e power m1x plus c2 e power m2x. The m1 value is 2 and the m2 value is minus 6. So this is the complementary solution. Now for the particular solution, using the shift theorem, 1 over d square minus 1 over d square plus 4d minus 12 into x minus 1 into e power 2x. Now take out e power 2x and replace d by d plus 2. So e power 2x divided by replace d by d plus 2 whole square plus 4 into d plus d minus 12 into the polynomial x minus 1. So a plus b whole square, d plus 2 whole square mean d square plus 4d and 4d plus 8 minus 12 into x minus 1. Now after simplifications we obtain e power 2x divided by d square plus 8 d into x minus 1. Now this is the polynomial, and the inverse operator upon the polynomial taking out the lowest degree term. This is taking common the lowest degree term. This is the lowest degree term. AD is the lowest degree term. So we can write e power 2x divided by AD into 1 plus d by 8 into x minus 1. Now 1 plus d by 8 shift to the denominator, we obtain 1 plus d by 8 power minus 1. And now binomially expansion, 1 plus x power n is equal to 1 plus nx plus n into n minus 1 divided by 2 factorial x square. D by 8 is actually represent the x term in the binomial expansion, 1 plus x power n, and n value is minus 1. Now just taking the two term of the binomial expansion, 1 plus nx. So n multiplied with this term 1 minus d by 8 into x minus 1. We need only the power of d, neglecting the d square and the higher power of d, because the second order derivative for this polynomial will be equal to 0. So we don't need d square and the higher power of d. Now multiplying this x minus 1 into 1 and into d by 8, you see over here d means the derivative of this polynomial with respect to x. So the derivative of x is you see over here x minus 1. The derivative of x is 1 and 1 derivative is 0, so 1 multiplied minus 1 over 8. Now 1 over d means actually the integration, and 1 minus 1 over 8 is equal to 9 by 8. So the integration of x is x square by 2, and the integration of 9 by 8 is equal to 9 by 8 into x. Now putting the complementary solution and the particular solution in the equation number a, we obtain the general solution is equal to c1 e power 2x plus c2 e power minus 2x plus the particular solution. This is the particular solution. Now another example. Now the exponential function is multiplied with the trigonometry, so we can use again the shift theorem. Y double dash minus 6y dash plus 13y is equal to e power 3x sine 2x. Now this is the second order non-homogeneous differential equation, so the complete general solution will be equal to complementary solution plus particular solution. For the complementary solution, again we take the homogeneous part, and this homogeneous part d square minus 6d plus 13 into y is equal to 0 is the trivial solution, and for the non-trivial solution we take the auxiliary equation m square minus 6m plus 13 is equal to 0. This is a quadratic equation. Now we can solve this quadratic equation by using the quadratic formula. M is equal to minus b plus minus under root b square minus 4ac divided by 2a. Putting the value of a is 1, the value of b is minus 6, and the value of c is 13. So m is equal to 6 plus minus under root 36 minus 52 divided by 2, and this implies that m is equal to 6 plus minus under root minus 16 divided by 2. Under root minus 16 means plus minus 4 iota, and now taking common 2 to cancel, we obtain 3 plus minus 2 iota. So the complex root alpha plus minus iota beta is equal to 3 plus minus iota beta. So alpha value is 3 and the beta value is 2. The roots are complex and different, so the complementary solution is equal to e power alpha x into c1 cos beta x plus c2 sin beta x. The value of alpha is 3, so e power 3x into c1 cos beta, the value of beta is 2, c1 cos 2x plus c2 sin 2x. So this is the complementary solution. Now for the particular solution, the inverse operator 1 over d square minus 6d plus 13 into e power 3x sin 2x. Now again using the shift theorem, take out e power 3x and replace this d by d plus 3. You see over here actually the argument of the exponential function is 3. So replace d by d plus 3 and take out e power 3x. E power 3x divided by replace d by d plus 3. D plus 3 whole square minus 6 into d plus 3 plus 13 into sin 2x. So d plus 3 whole square, a square plus b square plus 2ab, mean d square plus 9 plus 6d minus 6d minus 18 plus 13, and after simplifications we obtain e power 3x divided by d square plus 4 into sin 2x. Now this is actually the inverse operator for the trigonometric function sin ax. We have already discussed that replace d square by minus a square. The a value is 2, so replace d square by minus a square mean by minus 4 e power 3x divided by minus 4 plus 4 sin 2x, and this is the fail case. E power 3x divided by 0 mean undefined. Now taking the derivative of this d square plus 4, you see over here, and multiplied this function with the x, right, x, and taking the derivative of d square plus 4. So the derivative of d square is 2d and the derivative of 4 is 0. Now 1 over d mean the integration for the sin 2x. So x into 3 e power 3x divided by 2, the integration of sin 2x. The integration of sin 2x is minus cos 2x divided by 2, and this implies that the particular solution is minus x e power 3x cos 2x divided by 4. So the complete general solution is equal to the complementary solution plus particular solution. The complementary solution is e power 3x into c1 cos 2x plus c2 sin 2x, and this is the particular solution, minus x e power 3x cos 2x divided by 4. So dear students, I have told you about the particular solution, how to find the particular solution when in the non-homogeneous differential equation the right hand side function f of x is the multiple of two functions. One is the exponential function and other will be trigonometric or polynomial. So inshallah, in the next video lecture we will discuss the particular solution for the case when the function f of x is the multiple of a trigonometric function and a polynomial function. And now this is the end of this segment. Thank you. Allah Hafiz.